Hello, my name is Dave Torek, and I'm a Simulation Applications Specialist here at Hawkridge Systems. I'd like to welcome you to our Wednesday webinar series, where today's topic will be SOLIDWORKS Mechanical Conceptual, and specifically though, I'll be focusing in on the finite element analysis tool known as product design simulation. Our goal will be to provide a first look at this simulation product and show you how it works with SOLIDWORKS Mechanical Conceptual. Both of these products are coming from Dassault Systems, where there's been a lot of research and a lot of information's been gathered that companies are trying to do the best design possible as quickly as possible. And we believe that product design simulation is going to allow you to check during your conceptual phase and find out what's going on in greater detail than you could by just using SOLIDWORKS Mechanical Conceptual. Getting this information up front during the conceptual phase could help make sure that you don't miss any key design points as you move further through the design cycle. Over the years, we've gathered a lot of information, and mechanical designers require that there's a quick development of many different design concepts. And this is really the goal of using SOLIDWORKS Mechanical Conceptual. We're targeting this product to address the early part of the design cycle. Now, if I come up with 5 ideas, how do I know that these ideas are going to work? Typically, whenever I'm doing my design work, I'm not working in a bubble. I'm collaborating with others, or even as I'm evaluating my designs, I would want to be collaborating with others. In the early phases of design, we typically would be using, a lot of times, especially in mechanical design, it's faster to just make some napkin sketches, or perhaps just to use a whiteboard. Occasionally, using CAD software might be beneficial, but a lot of times it's just a little bit too slow and we have to put in a little bit too much detail in order to get the quick review of different conceptual concepts. And that's going to be what our 3D experience working with SOLIDWORKS Mechanical Conceptual as well as product design simulation is trying to address. With these products, they're part of the 3D experience. And being part of the 3D experience, our goal is to seamlessly allow you to create conceptual ideas, check to see if they are valid, as well as share them with the rest of your team. So the key is going to be having nice abilities as far as recording your conceptual ideas as well as communicating to everyone else. I can't tell you how many times I've had a great idea that's been on a napkin, and that napkin, when I finished eating my Subway, that napkin got thrown out and I lost my ideas. Our goal is to help not let that happen, or what happens at the end of the day if you erase your whiteboard. The design process is pretty common, in fact, this is just an example of one typical design process. And typically ideas will flow as quickly as possible in the initial stages. So this is a lot of times where companies resort to whiteboards or just putting their ideas on paper. Occasionally, a more developed design might be developed using a CAD system, whether it's just the 2D concept or creating a simple 3D model of it. And then once approval occurs is whenever we really kick in and we start using the SOLIDWORKS products that are available to us. Yes, we can definitely help out during the approval phase with our enterprise PDM solutions, but the true production 3D drawing has always been one of the strong points of working with SOLIDWORKS, as well as creating our production drawings. But we haven't really been able to address or really give assistance at those initial phases until we've come out with SOLIDWORKS Mechanical Conceptual as well as the product design simulation. So this initial phase is what we're targeting. We want to help the machine designers or the people doing a lot of mechanical design conceptually. We want to provide a tool that's going to allow you to capture all this information, share it, and move quickly through the design time with as good a quality as possible. It is a complementary tool. We're not trying to replace SOLIDWORKS. We're just trying to complement or give you another tool that you can use at the beginning of your design cycle. We want to make sure that you don't get caught up with the CAD program anymore. You can get your ideas quickly created and multiple scenarios that you can investigate using SOLIDWORKS Mechanical Conceptual or using the product design simulation software. All of this, as I mentioned earlier, is part of the 3D experience background, where anyone, anywhere, on any device is going to be connected to the data. All of our data is stored on the cloud, and the benefit of this is there can now be blogs or wikis where people within your organization can share or provide information to different users or different designers to get to the end result as quickly as possible. Resources for development as far as SOLIDWORKS Mechanical Conceptual go, because there's always a lot of questions. Is this going to replace SOLIDWORKS or is it not? And what we're currently looking at is that there has been a significant investment into SOLIDWORKS Mechanical Conceptual, but still SOLIDWORKS itself has at least a 2-to-1 favor as far as resources that have put into its development. So SOLIDWORKS is here to stay, and again, I just want to reiterate that point. With SOLIDWORKS being here to stay, our models are now transferable between the two systems, between SOLIDWORKS Mechanical Conceptual and SOLIDWORKS itself. And this new product, the highlights that I've been trying to emphasize so far, is it not only just deals with designing the part, but a better way for us to communicate and share those ideas within our team, get that feedback, and move through the design process. The 3D experience is the foundation of these new products, and SOLIDWORKS Mechanical Conceptual is on the left-hand side in the 3D modeling area. What I'm going to be discussing primarily today is the product design simulation product, which is part of the V+R. Moving to the top area, that's our social and collaborative area. This is where your SWM communities and your 3D spaces live. So this is where your data would be stored, and people have access and input into this anywhere in the world using any system. It's just a web browser that would open up, and you could go ahead and get into the data, provide your feedback, and allow things to keep moving on no matter where you are in the world. Over here on the right-hand side is the information intelligence area. And this is, again, that 3D dashboard, which works similar to the social and collaborative communities. And it'll be where you can customize the display within here. I've seen such customizations of not only having all of your parts or the record of your different concepts, but you can also have Gantt charts within here. So the goal is to really have a one-stop place where you use one suite of products to help you get your conceptual designs to market as quickly as possible. If you're interested in learning more about SOLIDWORKS Mechanical Conceptual, I'd recommend you come to our website, hawkridgesystems.com, and within the tutorials area, underneath 3D CAD tutorials, is the webinar that was recorded back in August by Todd Domke that really focused in just on the SOLIDWORKS Mechanical Conceptual component. Comparing the two products, they are connected. That's one of the key features we always try to emphasize in the 3D experience. And they will allow that social interaction of sharing your ideas together seamlessly, in fact. As we look at SOLIDWORKS Mechanical Conceptual, this is going to be where obviously your conceptual ideas are created. But are those conceptual ideas realistic? Well, before we go the whole way through the process, we can check using the structural validation tool from Simulia. So we call the entire suite of products product design simulation, and the real finite element tool is actually a Simulia product that we were calling structural validation. Now, SOLIDWORKS Mechanical Conceptual is instinctive, as well as our structural validation tool is instinctive as well, but it's quite powerful. It's based on the Simulia Abaqus software. So you're getting a very high-end finite element analysis tool, but what you're getting is you're actually getting a nice interface with that tool. So with product design simulation, we are addressing a new need for companies that are using simulation throughout their organization. We want to be bringing it in at the very beginning of the product design process. It's a simulation tool in the designer's toolbox and it allows for quick iterations and design comparisons. Now, we don't want a tool that requires an analyst if we're just going to be figuring out a lot of different conceptual ideas. So how did they do this? Well, we haven't simplified the technology by any stretch of the imagination. We're using the Abaqus solver that is, one of the industry standards, one of the premier simulation tools within the industry. But we're guiding you through that process, so you don't have to spend all of your time within the analysis software. You can get back to doing that design work that you love. The results of a designer simulation utilize this leading technology with on-screen feedback and assistance throughout the project, and you'll see this during my demonstration. And product design simulation will allow designers not to become analysts, but let them just move back and forth quickly between SOLIDWORKS Mechanical Conceptual and the product design simulation software to get the best results and to move through that design process. The goal here is really to make simulation an extension of the designer's CAD environment so that design validation really becomes an integral part of that conceptual development as we move through the cycle. A great example of how the product design simulation software has been able to achieve this is not only these panels that I'll be highlighting, but also the mesh is controlled using some proprietary technology that's been part of CATIA for many, many years as far as the CATIA analysis tool goes. And the tool is called the Octree. And what it's going to be doing is behind the scenes, it's going to be creating an automatic tetrahedron mesh, and it'll be checking that mesh depending on the settings that I use to find out the best possible settings to optimize my hardware as well as get sufficient results. When we're designers, we don't necessarily need to think about creating, research or fundamental research. What we need to think about is if this part is going to be strong enough. And if this part is strong enough, or if it's not strong enough, how can I fix it? Do I need to put on larger ribs, or perhaps can I get rid of the ribs and just make it thicker? Our goal with the Simulia Structural Validation is to let you figure that out quickly. Again, we're not trying to do fundamental research here. We're just trying to help you make sure your design is going to work as intended. Within the structural validation offering, you'll get the ability to do 3 different types of studies. We can provide a static study. We can do frequency studies where we can find out what the natural frequencies are of a part. So perhaps we are attaching a motor to something. We can make sure that we stay out of that motor's operating ranges. And we also have the ability to do thermal studies to find out how warm an object would get exposed to certain criteria, or how heat would be leaving that object, as in this example here on the right. The scenario that I would like to take you through is going to be working with this transfer gearbox housing. So within this design here, what we've got is we want to use an existing gear train. But what we want to do is make a simple housing. So I've come up with an idea using SOLIDWORKS Mechanical Conceptual. And I'm trying to make sure that this simple housing stays with a low cost and it's easy to manufacture. Some other limitations or some other design criteria that I have is it must be easy to maintain. So quick access to the components inside, or the ability to change them out very quickly and easily. Also, it's going to be exposed to a pretty harsh environment, so we need to make sure that it stays watertight throughout its operation. What I'd like to do now then is move into the product design simulation software. And within this, again, I'm using the Abaqus technology from Simulia, but I'm using a guided approach, and I'm just going to be following along with the standard workflow that I would be using to set up these problems. This is our interface for SOLIDWORKS Mechanical Conceptual, and when I want to start up my structural validation tool, all I need to do is come down to the bottom, and this area along the bottom, This is what we call, in any of our 3D experience tools, this is what we call the um, action bar. And within the action bar, depending on what I'm trying to do, is I'll go ahead and have different tools available. So in this case, I'm in the tools action bar and I want to go ahead and start up a simulation. It checks to see if there's any simulations saved with this product. In this case, there are not. So I'm going to go ahead and just start a new one. And that quickly and that easily, you'll notice that the interface doesn't really change too much as I go through this process from switching from SOLIDWORKS Mechanical Conceptual to Simulia Structural Validation. The goal is to get you used to one interface and let you keep using that all of the time. We have a little bit different action bars along the bottom now. So we'll be using those, as well as on the right hand side here, we'll be taking a look at our simulation status panel. And there's also this assistant here to help us understand what this color coding is, as well as throughout the process, I can come down here and learn more information about anything that I'm using. In this left-hand area here, this is my simulation manager. Very similar to the simulation tree that you might be using within SOLIDWORKS itself. Now, to get started, what I'll go ahead and do is it tells me that I currently have 7 parts included in this, which is great, but remember, we're already purchasing that gear train, so we don't need to necessarily analyze that. We feel pretty confident it's going to work to the design abilities that we want. So I'm going to use my tool here. If I just come over right here to setup, I can go ahead and specify what parts I actually want to be within this simulation. So I'm going to go ahead and get rid of this component. I'll go ahead and get rid of this component, and I can also get rid of it up here. Now, I'm not technically getting rid of it. You'll see it just remains ghosted on my display here. But what I am doing is removing that from the analysis. So I'm going to go ahead and add some forces and different connections later on to simulate the effect of these components. Well, now I'm down to just 4 materials, and none of those materials have anything assigned to them yet. So that'll be the next process that I do. I want to go ahead and assign some materials to this. I know I want to go ahead and add an alloy, like a 1350 aluminum alloy onto here. So what I can do is let me just type in alloy, and let's see what choices we get there. And let me just type in and try 1350 here. Yes. So there's a real powerful tool, which is we have the ability to search in different collaborative spaces, or we can search with different areas as well up here. So I'm just need to change my communities here a little bit, and let me just go ahead and search everywhere in all of my spaces, because my materials are in a different area. When I do this search again for alloy, in fact, let me just go to 1350, I now have the results that I'm looking for. So what I'll go ahead and do is just right click on this and go ahead and say that I want to apply this into my study here, as we're just bringing that information into the machine. Now, just like in SOLIDWORKS, there's several ways of accomplishing the same thing, and we have several ways to add materials within structural validation. Another way is to go and use the Apply Materials tool at the bottom of the screen. And in here, I can go ahead, and currently these are different materials that are active or that I've used recently within this particular session. So that 1350 alloy is popping up on here. So I'm going to go ahead and just select that. And then I come over onto my screen, and anything that I go ahead and I click on is going to have that definition. So I'm adding it to all of these different components. And if I'm done with that, I can go ahead and just close out that material browser. And now you see that, I've got 3 of 7 parts. So I do need to come back in and also still ignore those particular parts in the beginning. So I'll just redo that right now. get rid of this one right here as well. So we have one more material to add. Let's look at, that was actually my simulation manager that was available for me. So let's see which one's missing. We've got this one on the back side. So we'll go ahead and make sure that we apply some material to that as well. And I'll just rotate my part around, and there we go, it even looks different. So I'll select the component and I'll just click on the part, and now I have that added as well. Now that I've added the material, the next thing is for my parts to be connected. Since I've got multiple different bodies within here, what I need to now do is I need to let SOLIDWORKS know what happens between these different components. One thing I like doing as well is I'm just going to come down here to find my view commands, and I want to go ahead and change this to be shaded with edges. I kind of like that. Maybe not that one in particular, just this one. There we go. Now it helps me see my part a bit better here. All of my different components are touching, and I get the ability, whenever I work with my connections, is if I use contact detection, it'll find every face that touches each other, and it'll automatically bond them together. I also have the ability, if I want to control that and do it manually, I can use this next tool. This third tool is a really nice one where it's going to allow me to do a general contact where it will go through my model, find all of my touching faces, but what it's going to do is, and in fact this will be the one that I use in this example, is it's going to apply a certain friction coefficient between those components as well. So it's very similar to no penetration if you're familiar with SOLIDWORKS simulation, but it's going to add on the ability to have a little bit of friction between each component, or whatever I actually specify. So I'll click OK here, and that goes ahead and gives me a check mark now for parts connected. The next thing is bolts, but it has this green box around it, and it says it's optional, so I don't have to put in bolted connections if I don't want to, but I will in this case because I do want to show how these parts are bolted together. I love working with the bolted connections tool. What I'll go ahead and do is just pick on this circular edge right here, and it's ready to go ahead and define that as to where the head of the bolt will go. And then the part for my nut support, if I pick this cylindrical face, it's not going to actually be putting a nut, but it'll actually simulate that bolt being threaded into there. And so that nominal diameter now is now based off of that cylindrical face that I just selected. If I click OK, well actually before I click OK, I can go ahead and specify a bolt load. So we want to make sure, hopefully, that we don't have any dust or water getting into here. So I'm going to go ahead and make sure that that's applying a 250 Newton load onto my part. So it'll be tightened down until my part experiences that type of a load. It wasn't too terribly tough to do that work, but it would sure be great if it would intuitively be able to add the rest of those bolts in there for me. So let's see what we get. If I go ahead and just select this one bolt, I get a little pop-up right here. This is how I can edit that particular bolt's definition. Or if I choose this, my clone by search, it'll go through and looks for 4 similar holes, which it has, and it'll go ahead and when I click OK, it adds in those other fasteners. All of the work that I've done so far is being recorded in my simulation manager. The first is the components that are active within the simulation. The next one is going to be the scenario that I'm building up. I created a general connections with a 0.1 static coefficient of friction. And then I've also added in my different bolt connectors as well. I have 4 so far. Soon we'll have results that we can look at through this box. Well, the next thing we'll do is let's rotate around and we'll create a similar definition on the back side here. I'll go ahead and select this edge again. And we'll see, even just coming up, again, intuitively, it's providing some options for me. The one that I want to use is bolts. And I will go ahead and do that same process. I click my nut support, will be this face. And we need to also put in the preload, 250, and we'll click OK. And we'll select the bolt again, and we'll try to see if it can find the rest of them, which it did. Great. I'll let it do all that work for me. And then we'll finish up by just adding some bolts here on the top. Select the edge, look for the tool, great, and select the face that it's going to thread into. Again, just depending on your definition, on what you choose for the second will determine if it gets threaded or if there's actually a nut on the other side. On the top, we're not going to be experiencing nearly as much load, so we're just going to worry about 100 newtons coming down on there in each one of those bolts. And again, we'll select one and we'll propagate, and it looks good. Now that I've defined my bolts, and I actually have 13 bolts in this study, I need to restrain my model to keep it from moving. Just like adding fixtures within SOLIDWORKS, if I select this face on the bottom, it'll pop up that I could go ahead and add on a particular fixture. But we also have different action bar for working with restraints. When I choose a clamp, that's going to remove all 6 degrees of freedom, rotations, as well as displacements. Since we're working with the solid model here, we really just need to worry about holding on to those displacements so it won't be able to move at all. We can add symmetry, just like we would be able to in SOLIDWORKS. We can do displacement, so this could be where I would, if I knew there was a thrust load on here that at worst case it could push this 3 millimeters, I can go ahead and add that in here as well. We have the ability to add a ball joint, which is going to allow rotation about a specific face. And then we can also have sliders. So this would be, for instance, an object on top of a desk. And then the good old hinge, which again is going to allow that pivoting to occur. So what I'm going to work on here though, is I just want to put in a very basic, I'm just going to say that bottom's clamped. So that's not going to be able to move. And we'll go ahead and analyze from there. So my restraints have been applied. Now it's time for me, again, optionally, since it has the green box, to go ahead and add some loads if I want to. With this, I'll go ahead and pick a face, and let's see what it pops up there for me. I could still work on fixtures, but now what I want to do is I can come in and I can add different forces to it. In this case, I'm going to go ahead and put on a bearing load. And you can see my axis pops up on there for me. And I want to have a bearing load in the x direction, but actually in that negative x direction. So I'll put on minus 100 newtons. Again, this is just simulating what's coming into my gearbox from the shaft that I've removed. If I swing over here to the other side, we'll go ahead and do the same thing. And before I come up there though, I'll go ahead and switch my action bar on the bottom to kind of highlight these different tools as well. So we can apply pressures, we can do forces, we can do remote forces. So for instance, if I had a large wheel located onto this shaft, if that shaft was still in there, instead of defining the entire wheel as part of my simulation, I can just use this remote load to go ahead and signify a specific load that might be applied to that wheel. Similar concept is remote torques. And then we can also, of course, have gravity, and we can apply a translation if needed. And we'll do, instead of centrifugal force, which can be applied as well to simulate this object being rotated, we'll do another bearing load across the bottom here. Same thing, we're going to go minus 100. And we'll go ahead and click our checkbox. And now we've got those added onto there. And on this particular side, I know that there's a chance that there can be a force applied onto this face, a thrust load coming into my system. So what I can do is just specify that I want to apply a force right onto that face. And as I'm applying this, we also have the ability where we can switch. So currently my force would be applied in the Z direction. I can put in ways to rotate where that direction is going down here. But I can also choose an alignment tool, so I can align that to different using the global axis system. Or I can go ahead and actually move the triads myself, align it to a particular item, or even use this little robot. And that robot is kind of neat where you can kind of rotate what happens with it. So notice how I can move that up or down. get some kind of a unique orientation. And this could be real beneficial for me to find a very unique orientation without having to spend too much time putting in reference geometry within my simulation. For us though, we're just going to go back to the good old, we'll rotate that right around there and get that lined up on the proper axis. And let me just undo that, and we'll come in again and just apply it right onto this face. Now that I have it applied right onto that face, notice I accidentally had another one in there as I was clicking through there. So I can just click that icon and delete that right off, and it's now gone. I love having the icons on there, a nice way for me to go ahead and adjust, as well as I can look up here in my simulation manager as well. So we've got our bearing loads, we've got our forces on there, and one more thing that we want to simulate is a torque on this particular face. So if I just select the face, I can use my drop down for a remote torque, and in here we'll just go ahead and put on 10 Newton meters of torque. Well, I've got my loads applied, so I'm actually ready to go ahead and simulate this. And in the interest of saving some time so we can continue looking at all three of the different type of analyses that we can do using our structural validation tool from Simulia, I want to go ahead and just show you some of the results. So whenever I look at my first result file here, this is the same type of thing that we just worked on designing. So we've got those 4 bolts holding it in. And what we notice here is it looks like we've got very concentrated stresses. Currently I'm looking at my von Mises stress. But so with that concentrated stress, I'm a little concerned that I might not have the contact pressure that I need in order to have a good seal. Well, let's check that. I think we got a plot that'll allow me to look at that, and I do. I'll just switch it over to contact pressure. And, well, I really can't tell what's going on in there. Let me just pick this object that's kind of blocking my view, and I'll come over here to this particular item, which is display groups. And what it's going to allow me to do, whenever I pick over to here, is it has a dialog box that will let me go ahead and remove a particular item from my display. When I remove that, we can see what's going on a little bit better in here, and you actually see that we're not getting any type of a load in this region. Without any load in that region, we then have the issue where there's going to be water able to get into here, or dirt, or anything along those lines. So it's not really living up to the design requirements that I need. So knowing this information, I can go back into my SOLIDWORKS Mechanical Conceptual model, and maybe I'll go ahead and add some more bolt holes, which you can actually see that's kind of what I already started doing here. But I'll put in some more bolts. And another thing that, maybe I get some feedback when I put it out on my collaborative space using my, 3D experience tools, I can go ahead and somebody suggests putting a gasket in there. So let's see what our results look like if I put in that gasket and if I go ahead and put some more bolts in there. Whenever I do that, we can already see this is my von Mises stress again, and it's much better distributed across there. And it looks like we're going to be getting ready here to compare these two results. Let me just go ahead and get that back there. So let me come back to our first one. So now that I'm back to that first simulation, we can see how we looked over here with my contact pressure. And let me get this one set up in that same fashion. So we'll switch this to be contact pressure as well. And we'll go ahead and do the same type of thing. We'll remove this part so that I could see better what's going on in there. I could just pick it right off of my display screen. I'll click close, and now you can see that we've got much better distribution across there. We also have within here the ability to look at a lot of different feedbacks, one of which we can find the factor of safety within our system, our simulation accuracy based off of what our mesh size is. We can also take a look at compression and tension. And I find this one especially useful to kind of understand what my bolt loads might be. So if I look underneath my part here, we could see that really it's just this bolt here is probably going to be in tension. The rest of them aren't going to have too much of an axial load on them. That's the gearbox is more pressing onto the restraints at the bottom. So again, a nice way for me to understand and see what's going on in the model to help me understand how my concepts need to be modified and perhaps improved. Now, let me go ahead and close these two guys down here. And what I want to now focus in on is if I go back to the PowerPoint, we kind of have our results. And what we were able to achieve is we were able to definitely meet the ability to still have maintenance work nice. This cover's removable. It's going to be able to be in a harsh environment by increasing the number of bolt holes as well as putting a gasket in there. And we might have marginally increased the cost due to having more fasteners and a little bit more machining time. But on the whole, we are still able to achieve a very simple housing, and that housing would be able to withstand the loads that were experienced by the gearbox. We can also do not only static analysis, which I just demonstrated, but we also have the ability to do frequency analyses and thermal analyses. And I'm going to go ahead and show you first the results for these two studies. And then once I show you the results, what I'd like to go ahead and do is show you how they were set up. If I switch over, let's go ahead and get started with that robot arm first. So within this robot arm, this is where I went and created a frequency analysis. And in here you can see I'm currently looking at my fifth harmonic mode. And in here, we have all of the different, I told SOLIDWORKS, I told Structural Validation that I wanted to analyze the first 10 fundamental frequencies. So I have the results that I can switch between. And what's really useful in this is we kind of get an idea just based off the deformation what's happening. But if I just double click on that part, I can go ahead and overlay my undeformed shape as well. So I get a good understanding for what's going on in here. And in this particular model, all that I really set up that was kind of different is if I go into my simulation manager, all of my connections were handled by using that same approach, except this time, whenever I go down to my connections area, I made sure that they were just all bonded together. So that would be my first choice here using contact detection, and then they all become just bonded. The other new item that I did within this study was I used a different type of a restraint where I just used a ball joint, and that allows it to go ahead and rotate around the cylindrical faces that I picked. So in that case, what I ended up doing was I picked on these different areas. And if you ever want to get back to just looking at your model before the simulation occurred, we can go ahead and let me just reduce this guy down. And we can always come in and take a look at our tree display. And within our tree display, as long as we just switch over to our scenario, we're no longer in the results viewing mode. And then I could go ahead and start doing work or reviewing what happened when I set this up. So the ball joints, and I'll just let that minimize there and we'll bring this out, is if I look at one of my ball joints and decide to edit it, all I did was I selected these two cylindrical faces and I just told SOLIDWORKS that that was going to be a ball joint, so it can now rotate around those cylindrical faces. And that's how it's been constrained from moving. With that, I had all of my check marks done, my material was already defined, and then I was ready to go ahead and analyze my results. Looking at this brake rotor, the brake rotor, we can go ahead and we could find out the temperature of all the components in here. And if you notice that the display is kind of horizontal here, if you're used to seeing SOLIDWORKS where it always has that vertical display, I can just switch that right here to make it be the vertical display, and now it's shown in this fashion. So I can look at my temperature, or if I want, I can go ahead and look at heat flux. And within heat flux here, all I've really done is I've just selected, I told the simulation that I wanted this face right here, as well as the back face of this rotor. I wanted those to be a certain temperature, and then I only defined a few faces where energy was actually able to leave my model. You could probably figure out where those faces were by just looking at the results. But another great tool, which I haven't shown yet, is being able to view your results with a cut. So in here, we can use this little robot to kind of drag around how that cut's occurring. Maybe I'll bring it up in this orientation, and then I'll grab this direction and we'll rotate it around over to here. And then when I go ahead and say OK, it removes the out of there so that I'm just looking at my results in that particular area. Now, how is this study set up? Well, let's come over here and take a look. We used contact connections, but this time, whenever I go ahead and define a contact connection, if I say that I want to edit this particular item, which I just need to, again, come back into my simulation tree and switch it over to be scenario. When I'm in here, I've got a great representation. I love how it really helps me understand what's going on as far as I've modeled this. But within here, and in fact, I'll just pick it right off the screen. We don't even have to get into there. But if I click on this little icon here, I can go ahead and say that I want to edit that. And this is how I've went in and described the heat flux. So I really just picked the back of the brake pads and the top of the rotor and specify that there can be 5,000 watts per meter squared, or 5,000 watts times meter squared, leaving this particular component. As far as what the temperature is going into it, I told the structural validation software that I wanted the top face and the bottom face to be 400 degrees. So I know when I do my braking that could heat up as high as 400 degrees. We could go ahead, I haven't shown this tool either, but this is one of my favorite things that I can do within SOLIDWORKS is if I want to go ahead, perhaps I want to put on a film condition so that I can represent convection. One thing that I could do, if I just hold down Shift when I select a particular face, it pops up this propagate tool. And this propagate tool, it's going to allow me to propagate either by tangency, by curvature, or in this case by angle, any face that is, and let me go 91, so that way I'll get everything. When I click propagate, it just very quickly and easily selects all of those faces for me. And now in this case, I could go ahead and put on a convection coefficient, so to speak here, and then I can also put in a reference temperature for what that air is going to be, and then I could model convection. We also have the ability to model radiation as well, so all three modes of can go ahead and be taken care of as well. So using this tool, you can add radiation to your study. Looking back at our PowerPoint file, we take a look again at the results. This one was a temperature plot that I went and did the cut, a section cut on as well. So with product design simulation, you get a very guided approach to using Simulia's Abaqus technology, and the results of that will help you as you try to evaluate your conceptual products. Just to remind you about all of the simulation products that are available in the SOLIDWORKS and the SOLIDWORKS Mechanical Suites, I wanted to bring up this slide and discuss. Because we've been for quite a while now been representing and offering Simulia as another solution if you need more advanced finite element analysis. We've always had the offerings whenever you purchase SOLIDWORKS Premium, you have the ability to do a static analysis and to also do motion analysis so you can find out how large a motor has to be, for instance. If that's not enough and you've got questions as far as what the natural frequency of your components are, or perhaps you're worried about fatigue, maybe you've got a component that needs to withstand 1,000,000 cycles and you're not sure if your design is going to be able to do that. We can help you answer those questions if you purchase the SOLIDWORKS Simulation Professional product. After that, though, if you're ever wondering about, perhaps you've got some nonlinear situations where, we've got some pretty large deformations, or maybe it comes in contact with another part and we want to model that real accurately. That's going to be when we might need to start thinking about using SOLIDWORKS Simulation Premium. So we can do nonlinear analysis, we can do time histories, we can model composites. We have the ability to do a lot of dynamic solutions, so we can simulate putting this onto a shaker table and finding out what its responses would be, or if it's provided a shock load, what is going to be the stress that occurs within your model. So some great tools that could further help you in your analysis of your parts. But if that's not enough and you still need more, we have Simulia now that we represent, and they've got a lot of different abilities out there. In this presentation, I just want to highlight 3 of them that come as part of their standard process, and we can do standard, explicit, and CFD solutions using Simulia. And this is going to be, if the abilities within SOLIDWORKS Simulation all the way up to SOLIDWORKS Simulation Premium aren't enough, then Simulia might be what you want to take a look at, and we'd love to get a chance to discuss with you some of those options and what it really can do. Also, there's always the addition, if you have some flow considerations, there is still the SOLIDWORKS Flow package that you can purchase as well. But SOLIDWORKS' simulation products are staying where they are. We have the product design simulation that is now packaged and can work in conjunction with SOLIDWORKS Mechanical Conceptual. So that kind of fits that niche of conceptual design. And then if you're not worried about the conceptual side, and if our SOLIDWORKS simulation products aren't quite giving you enough analyses information, then Simulia might be the ticket for you, and we can again help you determine if that's going to be a great product fit for you or not. I want to thank you for your time in attending today's webinar, and we have some more webinars coming up in the near future. So next week we've got a full schedule. We always have the e-learning start at 11 a.m. Pacific time, and your eDemo, well, that starts at 1 p.m. Pacific time. Here are the items. If you're interested in learning more, please just go to our website. Also, if you're interested in learning more specifically about what's new in SOLIDWORKS 2015, we've got our launch events are starting next week. So myself and my coworkers are looking forward to presenting to hundreds of different individuals like yourselves all of the great features related to SOLIDWORKS. If you wanted to register for this event, if you haven't already, please go to this website, and this would be hopefully where you can find a meeting that's going to be close to you. And this information is great to learn not only what's new, but you get a chance to see perhaps how to solve some of your problems in SOLIDWORKS that you never thought you could.